Hello everyone. Uh, Today we are going to discuss the topic that is degree of freedom. The degree of freedom is defined as it is the number of independent relative motions, both translational as well as rotational, that a pair can have. So in theory of machine we have learned what is a pair. So I will not discuss that here in details, but a degree of freedom, we can say a number of independent relative motions. So, if I consider any object which is in the space, so for that object, how many degrees of freedom, that is independent relative motions, that can have. So, that object can have, we can imagine that it can have three translatory motion, that is along x, the axis, y axis and z axis. Along with this, it can have rotary motions about x, y and z axis. So I can say that object can have 6 degrees of freedom, that is 6 number of independent or 6 independent relative motions. Okay. So in other way, we can define a degree of freedom as 6 minus number of restraints. Now, what is this number of restraints is, or how this formula has came into existence? That is, as we have seen that any object that is in space can have 6 degrees of freedom, that is its maximum number. So the degree of freedom is here, it is defined as it is 6 minus number of restraints. So number of restraints means number of restrictions that is provided or that those are present in the system which is not allowing that object to move in that particular direction or about that particular axis or along that particular axis. That is what the number of restraints is. So if any object, for example, if any object is in the space and if it is fixed on one of the axis, that is say at x axis, then at that time what will happen? Okay, at that time that object will not be able to rotate about that axis and will not be able to move about that particular axis. Say for, if I have taken example of x axis, so along x axis it will not be able to move as well as it will not be able to rotate. So I can say that there are two restraints, those are present for that particular object. So here if I want to calculate that degree of freedom, it will be 6 minus 2. So that object in the space will have 4 degrees of freedom. That is how the degrees of freedom is calculated by using this formula. Okay. Now in order to have more clarity about degree of freedom, we'll see one of the example. Now in this picture you can observe a door is there which is open right now. Assume that that door is separated from the frame and it is in the space. As I explained earlier, that object which is in the space can have degrees of freedom which will be equal to 6. So here that object we can consider as a door. So how many degrees of freedom it will have? It will have 6 degrees of freedom, that is 3 translational motion along x, y and z axis and 3 rotational motions about x, y and z axis. Now the door is attached to frame. Okay. Now what will happen? The door is having only one rotational motion about vertical axis. Now here if you remember our second slide where we have defined degrees of freedom as 6 minus number of restraints. Here the number of restraints, if I want to calculate them, the number of restraints will be 3 translational motions, okay, about x, y and z axis. As the door is fixed to the frame, the door will not be able to move in any of the along any of the axis, okay. Also it is able to rotate about only vertical axis, so the rotation about other two axes is not possible. So I can say number of restraints or the constraints imposed on two rotational motions and 3 translational motions. So total number of restraints will be 5, and by the formula we'll get degrees of freedom as 6 minus 5 equal to 1. Let us take another example. Assume that the bolt of door is removed and it is in the space. Now similar to previous example, it will have 3 translational motion and 3 rotational motions. Now suppose the bolt of door is attached to door. Now this time what will happen? It will have 1 translational motion, that is in the horizontal direction, and 1 rotational motion. So the number of restraints imposed will be how much? It will be 4. And if I want to calculate degrees of freedom, it will have 2 degrees of freedom, that is 2 independent parameters, or I can say 2 independent motions are there for the bolt of door, that is 1 translational and 1 rotational motion. Now this picture shows various possible examples for degrees of freedom. Here we'll understand what will be the minimum degree example of minimum degrees of freedom and example of maximum degrees of freedom. So we'll see it one by one. If you see the first picture, in the first picture the object is rigid, so as there is no motion, the degrees of freedom will be equal to 0. Now if you go for the second object, which is a prismatic bar, that prismatic bar is having motion along the only one direction, that is only say z axis, about z axis, then the degrees of freedom for that prismatic bar will be equal to 1. Now if we go for C picture, in that picture you can see the vertical there are 2 plates which are pin joint. The vertical plate can rotate about the vertical axis, so it can have degrees of freedom equal to 1. In another picture, that is in picture T, there are 2 parallel cylinders. For these 2 cylinders, in order to have contact between them, okay, there will be 2 motions, that is one along the axis of the cylinder and other is rotational motion for about the axis of the cylinder. So the degrees of freedom for this will be equal to 2. If you take another, that is if you see picture E, there are 2 cylinders which are one cylinder which is inserted in another one. In this example, there will be a translatory motion along the axis of the cylinder and second rotational motion about the axis of cylinder. So degrees of freedom will be equal to 2. Now if we see picture F, this is a spherical joint. The practical example of spherical joint is a mirror of our vehicle. That is, if you see a mirror of a two-wheeler, we can say that it's a spherical joint. Now for this, how many possible motions are there? So in picture the arrows are shown. You can see there are three uh, uh, that spherical bob can have motion along the three axes. That is, all the motions are rotational motions. There is no translatory motion. So if there are rotational motions, then if those rotational motions, number of rotational motions are 3, I can say that that spherical joint will have 3 degrees of freedom. Okay, we'll go for next, that is G. In picture G, you can see a square plate is kept on the rigid surface. So for that, how many possible motions are there? The arrows are indicated. There are 2 translatory motions that are possible. Okay, and the another motion that is possible is the rotational motion, which is in the vertical, along the vertical axis. Now here the question arises, that is, if the plate moved up, that means there are 2 arrows which are indicated. One is horizontal, that is 2 arrows indicated in horizontal plane. What about the arrow which could be indicated in vertical direction? So the motion is in that case possible, but what happens is the contact between the two object, that is a plate and the surface, will not be there if we lift the plate from the surface. So we cannot say that it is a pair. So in that case, if it doesn't remain a pair, we cannot calculate degrees of freedom for that particular pair. So the degrees of freedom equal to 3. The next example is H. Picture H. In picture H, we can see it is a edge slider. In edge slider, there is a line contact between the edge slider and the surface. So the possible motions are the one motion which is a translatory motion in horizontal direction, another translatory motion in say vertical direction, and remaining motions are one rotational motion about a vertical axis and one rotational motion along the axis of the edge slider, that is along the edge of that edge slider. So number of degrees of freedom will be 4. The another example is cylindrical slider. That is, suppose a cylinder is placed on a flat surface. In that case, how many possible motions are there? So for this, the possible motions are 1, that is a motion in horizontal direction, that is rolling motion. Another motion, that is translator motion, will be along the axis of the cylinder, and rotational motion about the axis of the cylinder and along the vertical axis. So total number of possible motions will be equal to 4. So degrees of freedom will be 4. The another example, that is next picture, is J, which is a point slider. Now the point slider is having a point contact with the surface. So if we see the total rotary motion and translational motion, if we calculate, then we can get there is only one motion that is not possible, that is a translatory motion in the vertical direction. Okay, remaining all motions are possible. So the degrees of freedom for this point slider will be equal to 5. Now next, picture K and picture L. Both picture shows the only one motion that is not possible, and that motion is in vertical direction. So degrees of freedom for this all these three examples, that is J, K and L, will be equal to 3. So that all this information is summarized here. If we go for the previous slide, you can see that the various arrangements are there, that is rigid, prismatic, revolute, parallel cylinder, cylindrical, spherical, planar, edge slider, cylindrical slider, point slider, spherical slider and cross cylinders. All are mentioned here along with their restraints, that is in translatory motion and rotary motion. So for rigid type of pair, translatory motion are restraints, that is all translatory motions are restrained, all rotary motions are restraints. So number of translatory motion mentioned here are 3 and rotary motion mentioned here are 3. So the degrees of freedom will be equal to 0 as total restraints are equal to 6. And in second slide we have mentioned that degrees of freedom is equal to 6 minus number of restraints. So in first example, as total restraints are 6, the degrees of freedom is calculated as 0. Similarly for other examples. Now here are some examples are given to calculate degrees of freedom for the mechanism. So we'll try to solve the degrees of freedom.